Welcome to our tutorial on the illustrated library of hydraulic components. In this video, we will explore how this library can facilitate the design and simulation of hydraulic systems in various engineering projects. We will divide this demonstration into three sections: the cylinder library, the cross-sectional view library, and the illustrated components library. We will start with the illustrated cylinder library. This library allows us to represent the cylinder and pressure resistance using masses, friction, pulleys, or the simple weight of the mass. To do this, we can also play with the inclination and the effect of gravitational force or the friction coefficients. In this case, we have one of the simplest hydraulic systems, the extension and retraction of the cylinder. We can vary the cylinder's degree of inclination and also force a dead point that isolates pressures on each side. This allows us to observe how different factors affect the cylinder's functioning and how these conditions can be simulated in a real system. Let's move on to the illustrated cross-sectional view library. This library allows us to represent the hydraulic components from the inside, showing their functioning schematically. By using the cross-sectional view, we can visualize the internal pressures and flows, which is especially useful in educational contexts to fully understand the functioning of each component. As an example, we can see two directional valves, each directing a double-acting cylinder. We also have a tank with an integrated filter, a flow meter, a gear pump, a relief valve, a pressure gauge, and two variable throttle valves. When starting the simulation, we can observe the system's behavior while varying parameters such as the directional valves or the throttle valves. Finally, we will explore the illustrated components library. In this example, we have the same system as in the cross-sectional schematic, but with the elements illustrated as mentioned in the explanation. This library offers a detailed visual representation of each component as it would appear in a real installation. It includes valves, actuators, motors, and other common components, presented in a way that makes them easy to identify by comparing them to a physical installation. Additionally, the use of illustrated components makes the simulation more intuitive, allowing engineers and technicians to better understand the system's behavior. For more information about Automation Studio software, we invite you to visit our website. Thank you very much for watching this video.